As a reminder, question letter F wanted us to determine the absolute min and absolute max of big F of x. So as a reminder, minimum and maximum can easily be extracted from our line chart if we use a little bit of critical thinking. I'm going to go back to my line chart again, and I'm going to think about what we know about the behavior of our snow function. The snow function is going to start out increasing. And if you're wondering how I know that, it's because I'm looking at that plus sign situation and reminding myself that's what it means when a line chart has plus signs in this context. Big F is increasing where its line chart for F prime is positive. So starting at time 0, we're going to have a graph that increases. Then at time 3, it's going to go flat for a second, and then it's going to turn around and decrease. And again, I can tell that for the next couple of hours, it's going to decrease until we hit time 5. Again, because our line chart is negative there, that tells us we must be decreasing until we hit time 5. Then my graph is going to stop again and turn and head positive again for just a little while, just an hour and a half, until I get to time 6.5. Then it's going to stop again, and it's going to turn back to decreasing until I get to time 8. Now I'm just estimating, of course. I have no idea what the real graph is supposed to look like, but I know that this is its general behavior. It goes up, then flat for a second, then down, flat for a second, then up, flat for a second, then down. So if I think about the peaks and valleys, so to speak, let's see if we can make some sense of them. I have possible maximum values at time 3 and at time 6.5. Those are possible or local maximum values. A possible or local minimum value could occur at time 5. Maximums would be those tops, and a minimum is any potential low point. So top of the hill, bottom of the hill, if you want to think of it that way. The unfortunate thing is that I don't know about the endpoints 0 and 8. I kind of winged it on my graph. I don't really know. Like maybe 0 is up here, maybe time 0 is way down here, maybe it's a minimum. I don't really know. Same thing with time 8. I don't really know that either. So that's the thing about the absolute min and max. We have to check the endpoints too, just to make sure that we know what those values are. But let's at least keep in mind these possibilities. I have possible maximums at 3 and at 6.5. I have possible minimum at 5, and then the endpoints are going to be unclear. So let's see if we can figure out which is which. I'm going to list my possible maximums in my side work here, or in my scratch space. So possible max points could be at time 3, at time 6.5, and maybe at the end points 0 and 8. Possible minimum points could occur at time 5, and again time 0 and time 8, not really sure. So those are my possibilities. But how will I know which ones are really mins and maxes? How exactly am I supposed to know? Well, if you remember, the x-coordinates, or in this case the t-coordinates, are when the possible max and min could occur. But we actually have to find the true value of those times, which means, in reality, we're finding the true value by using big F and testing those points. So I need to find big F of 3 to see if it's an absolute min or max of the big F function. I have to use big F of 6.5 to see if it's a possible max. Big F of 0 to see if it's a possible max. Big F of 8 to see if it's a possible max. And same thing with possible min. I have to find big F of 5, big F of 0, big F of 8, and I have to test those time values to see which ones are actually the biggest possible value of F, that'd be the possible maximum, and the smallest possible value of F for the minimum. This is the same thing we used to do when we did max-min problems way back in chapter 3. It's just been a while. So we might need to dust off that part of our brain if it's been a while and we just kind of need to remember. Now, if I need to test these possible points, that means I need to plug 3 into the big F function. I'm thinking, oh gosh, what is the big F function? I don't remember. So I'm going to look back at my old work. Oh, wait a minute. Big F. That's the area function. I did a bunch of areas. Don't I already have big F of 3? Oh, I do. Let's look at my table. These are big F values in my table. And since I already did big F of 3 in my table, I got 6.5. Hey, I'm just going to use that. Big F of 3 is 6.5. Why reinvent the wheel? I've already done all the work to figure out big F in the first place. Now I'm going to benefit from my own hard work earlier. Now let's use the big F function from the table to get the rest of these numbers I need to test. Big F of 6.5, going back to my table, is 3.25. And again, I have to test my possible endpoints. Big F of 0 is 0. And big F of 8 is 2. So of those possible values, which one appears to be the biggest possible value? Well, it looks like it's 6.5. So the maximum appears to be 6.5. Let's use the same logic and the same procedure to see if we can figure out which one is the minimum. Big F of 5, and back to my table, is 2.5. Big F of 0 is 0. And big F of 8 is 2. So of those values, I'm looking for a minimum value. The smallest possible one must be 0. So the absolute min that we found is going to be 0. And the absolute max that we found is going to be 6.5. And again, we can confirm that because those were the absolute smallest and the absolute biggest values that we found in the table. And it actually makes sense. If you go back to your table, we didn't have any numbers smaller than 0. 0 was really the minimum. And we didn't have any numbers bigger than 6.5 either. 6.5 really is the maximum. So common sense actually could have dictated this answer, but we know that calculus reinforces it. So hopefully you can see why these answers make sense. Speaking of making sense, try to answer question letter G. In context, what do the min and the max have to do with snow accumulation? Try to answer that question in your own words and put it kind of in the same phrasing that we use for letter E. Try to think of it in terms of the number of inches of snow and see if that helps you make some sense of it.